Should the tip of a temperature sensor touch the bottom of the thermowell? Here's an interesting question. Should the tip of a temperature sensor actually touch the bottom of the thermowell, or should it not? According to many engineering guidelines, the sensor tip should be in contact with the bottom of the thermowell. But, why? The answer seems straightforward. For the most accurate temperature measurement, and the fastest response time, heat must transfer efficiently from the thermowell to the sensor. That means good metal-to-metal contact. So at first glance, the recommendation makes perfect sense. But here's where things become interesting. Many temperature sensor manufacturers recommend something completely different. Instead of touching the bottom of the thermowell, they recommend leaving a small air gap, typically between 1 and 3 millimeters. So now the obvious question is, why would manufacturers recommend something that appears to contradict engineering guidelines? The reason is thermal expansion. As temperature increases, the metal sheath of the sensor expands. If the sensor tip is pressed rigidly against the bottom of the thermowell, thermal expansion can create mechanical stress right at the sensing tip. Over time, that stress may damage the sensor, or reduce its long-term reliability. There is another important point. If the sensor length has been selected so that it already reaches the bottom of the thermowell, simply tightening the threaded connection during installation can force the tip even harder against the bottom. That extra mechanical load alone can damage the sensing element before the process even starts. Based on these recommendations, it sounds like the best solution is to always leave an air gap between the sensor tip and the thermowell. But then another question appears. Who is actually right? The engineering guidelines, or the manufacturers? The answer is, both are right. The difference is that each recommendation applies to a different operating condition. For relatively low temperatures, thermal expansion is very small. In most applications below approximately 150 degrees Celsius. Allowing the sensor tip to touch the bottom of the thermowell is generally acceptable. It provides excellent heat transfer, good accuracy, and a fast response time. However, once the operating temperature rises above 150 degrees Celsius, the situation changes. Now we still want the sensor tip to stay in contact with the thermowell, because that gives us the best measurement performance. But at the same time, we must prevent excessive mechanical stress caused by thermal expansion. So how do we achieve both? The answer is a spring-loaded temperature sensor. The sensor length should be selected so that after installation, the internal spring is compressed by approximately 3 millimeters. The spring continuously pushes the sensing tip against the bottom of the thermowell, maintaining excellent thermal contact. At the same time, the spring absorbs thermal expansion, reduces mechanical stress, and protects the sensing element from damage. So in the end, we don't have to choose between accuracy and reliability. With the correct spring-loaded design, we achieve both. Fast response, high accuracy, and long service life.